So I realize there's worksheets in ABYC E11. There's a DC calculation worksheet and an AC calculation worksheet. Can you give me an example of how they would work or what information we would need?
Sure. Well, again, amperage is key. The other piece, the DC work table within the E11 standard divides direct current loads into two categories. One would be continuous duty. Think of it as mission critical components versus intermittent or not so mission critical components.
Can you give me an example?
Things like a horn, for example, an electric horn. It's going to be an intermittent device. So that would go in what we call as column B in the E11 standard. In the column A, you're going to have things like running lights, for example, which are mandatory under U.S. Coast Guard regulations for running at night, and perhaps a VHF radio or GPS receiver. Things like that are going to fall into the mission critical category, and so we're going to take those at full face value, and in our intermittent use or non-mission critical column, we're going to separate it out. Things like an anchor windlass, for example. It's a very high current draw item, but it's used intermittently. It's not something it's going to be operating on a full-time basis ever.
So it seems that one of the key criteria here is to have the amp rating of the individual appliances or accessories,
Correct.
Whether it's AC or DC.
Right.
What are some of the ways that we can get the information? You mentioned before about tags on equipment.
Yeah.
So are there any other ways that we can do this?
Well, yeah, if you have the luxury of having the owner's manual that comes with a piece of equipment in question, it's going to be in there. Some years ago, the ABYC Electrical Committee did, at my request, actually pass create a standard that now requires labeling on DC equipment similar to what we see on AC equipment. Unfortunately, a lot of the manufacturers are not really following up with that, so you may or may not see it as a label on a piece of DC equipment. But owner's manual or measuring it yourself, you may have to connect and run this piece of equipment and use an amp clamp on a DVOM meter and actually see how much current the device draws. So either via a label, if you're lucky, certainly the documentation that comes with the equipment, and that's becoming much less of a problem, honestly. You can go online today and find, if you have the model number of the piece of equipment, you can go online today and find just about any sort of documentation you're looking for.
So when I look at that documentation from the manufacturer, I just need to know the fuse rating. Will that help me if I know the fuse rating? Or if I go to the panel and I see the breakers, can I just add up all the breakers?
You don't want to confuse fuse ratings or circuit breaker ratings with actual consumption, Rob. They're not going to be the same. The E11 standard is pretty clear in that overcurrent protection devices are there to protect wire, not the equipment. And so what comes into play here is the overcurrent protection devices, at least based on the standard, are rated to ensure that the wire cabling supplying the device doesn't get overheated and melt the insulation and cause an electrical fire. So there can be a great disparity between the actual current draw of the device and the overcurrent protection rating for the fuse or circuit breaker that's protecting the wire run supplying the circuit.
I think that's an interesting item, that the circuit breaker or fuse is there to protect the wire. Most people, I think, would agree that they think the purpose of it is to protect the component that's downstream.
Absolutely not. The E11 standard and even the European standard is in the ISO is quite specific to protecting the wire runs. If an equipment vendor wants to install an internal fuse to protect their device, that's fine, but it's going to be entirely up to them and totally separate from any standards compliance requirements.